So we're going to solve this sucker right here. We're going to start with putting our coefficients into an augmented matrix. So we've got a bunch of 2's, line for the equals and 0, -2, 5, 2, 1, 8, 1, 4, -1. Nailed it. All right. So we're going to start by making this first column into 1, 0, 0. So our first step, we're going to make that 1 by taking row 1, dividing it by 2. So we got a bunch of 2's here, so that'll look pretty nice. So we'll end up with a 1, 1, 1, 0. Leave these other two the same for now. Now what we're going to do, we're going to use that 1 we just created, and we're going to cancel out the entries below it to make these zeros. So we're going to do 2 steps at once. So let's do a little diagonal arrow over here. And what we're going to do is, we're going to do row 2 becomes row 2 plus 2 row 1, and row 3 becomes row 3 minus 8 row 1. Since I have the 1 here, we just use the opposite sign. That's going to cancel that out for us here. So that's what we get. Nothing's going to change for our first row. For the second one, we're doing each entry plus 2 times the entry above it. So we'll get a 0, 5 plus 2 is 7, 2 plus 2 is 4, tough one. 1 plus 0 is 1. For our third row, now we're doing -8 times 1 above it, so we're going to get a 0. 8 minus 8, 0. 1 minus 8, -7. 4 minus 8, -4. -1, -0, -1. Okay. So now we're going to focus on this next column. So usually what we would do first is we would divide the second row by 7 to make this a 1, but we can already see we got something nice going on here. We got row 3 is just the negative of row 2 here. So let's just clean that up with a nice little step. So let's do here, let's just add these two. So we'll do row 3 plus row 2. That's going to be our new row 3. That should cancel out everything real nice, right? So we'll end up with 1, 1, 1, 0. We're not going to touch row 2 at the moment. Row 3 is going to be all zeros now, right? Because we'll do -7 plus 7, 0, -4 plus 4, 0, and so on. Okay, so we can already see we're going to have infinitely many solutions. So depending on your method of solving, you could stop here. I'm going to take this thing all the way to reduced row echelon form. So what we would want to do to accomplish that, if we do a little zigzag to the left here, well, we want to make the 7 into a 1, right? We can only have 1s as our leading entries in each row. So we will take row 2 and we'll divide it by 7. We're going to end up with some fractions here, but we'll be tough. We'll figure it out. Leaving row 1 the same, we've just got 1, 1, 1, 0. Now I'll have 0, 1, 4 sevenths, and 1 seventh. Some zeros at the bottom here. Let me fix that 4. That is an ugly 4. Okay. So now, the last thing we want to do to finish our row reduced echelon form, in row reduced echelon form, can't have something like this. You have to have a 0 above and below any 1s. So we want to cancel that guy out. But since it's a 1 and 1, we can do that with a nice little row 1 minus row 2, replacing row 1 there. So let's do that. So we'll do 1 minus 0 is 1, 1 minus 1 is 0. 1 minus 4 sevenths is going to give us 3 sevenths. 0 minus 1 seventh is going to give us a -1 seventh. And then we'll have 0, 1, 4 sevenths, 1 seventh, and a bunch of zeros. Okay. Last step here, we just want to write out our solutions. We are going to have that our x3 variable is free because it's got no pivot in there. So what we're going to do is we're going to try to rewrite each of these equations and write them in terms of x3 since that's our free variable. So our first equation will say x1 plus 3 sevenths x3 equals -1 seventh. Our second equation will say x2 plus 4 sevenths x3 equals +1 seventh. So we just want to solve each of these. Let's flip these around. We can see here that x1 is going to be -1 seventh minus 3 sevenths x3. x2 is going to be +1 seventh minus 4 sevenths x3. That tiny little one. There we go. Okay. So now we just want to introduce x3 as a free variable by replacing it with t, any real number t, and then we can write our final solution in parametric form. So say let x3 equals t. This is any real number. Okay, so then with that, we would just have that x1 is like -1/7 minus 3/7 t. x2 is 1/7 minus 4/7 t. And x3 is just t. Okay. All right, so we can either leave our answer like this, or we can write it in a vector form. So I'm going to write it as a tall vector, x1, x2, x3. So we'll write that as -1/7 minus 3/7 t, 1/7 minus 4/7 t, and t is our x3 entry. And for either of these, right, it would be good to clarify t is any real number. So you get infinitely many solutions here. You can pick your favorite real number for t. You could make it 1, 0, pi, e, anything crazy, a billion. Plug it in, get the values. That's a solution to your equation.